Welcome to the online lectures for software engineering. In today's class, we'll be discussing the topic assessing the alternative architectural designs. Now, within this, the first topic is architectural trade-off analysis method. The short form is ATAM. Now, this ATAM, it was developed by the Software Engineering Institution. The SEI has developed this ATAM. Now, what is this ATM? This ATM, it is an evaluation process. It is an evaluation process so that what type of evaluation is done here? The evaluation process is done for the software architecture. And this evaluation process, this is iterative process. Now, what do you mean by an iterative process? Iterative process means once you've completed a set of 3-4 activities, you're again going to start from the beginning until the entire software architecture is being developed. So the first step here is collecting scenarios. Now, whenever you encounter the word scenarios, it means what type of diagram that you're developing. It is the use case diagram that you're developing. Now, what is the job of this use case diagram? This use case diagram is developed so that it can represent the system that you're developing from the user's point of view. That is what the user thinks of the system, that you can get to know from the use case diagram. The first step is collecting the scenarios. The second one is eliciting requirements, constraints, and environment descriptions. Now, within this, as the term requirements come, whenever you're collecting all the requirements, this is collected at the requirement engineering phase. So all this information, you're going to collect all this information, and you're going to see that whether all the stakeholders' issues are addressed or not, or the stakeholders concerns are addressed or not. Now, what are going to be the concerns of the stakeholders? Those concerns are going to be that if suppose the particular stakeholder wants some specific feature or some specific requirement is there, some specific specification is there, or some requirement of technology is there, whether all the different stakeholders, whether they are satisfied by the development of this architecture or not, that is going to be identified within the second step. Then the third one is describe the architectural styles and patterns. That is what type of style or pattern that you're using. You're going to select that pattern based upon the scenarios and requirement of the system. You're going to select the different styles and pattern that suits your system. Then the next one is evaluate the quality attributes. Now, what are quality attributes? These quality attributes, this can be reliability, performance, security, maintainability. It can be flexibility, testability, portability, reusability, interoperability. So these are your different quality attributes. You're going to evaluate all of them, whether the system that you're developing is reliable or not, whether it gives the best performance, whether it is secure enough, whether the components of the system, whether they can be reused or not. These all things are going to be evaluated. The next point is identify the sensitivity of quality attributes. Now, first you have defined the quality attributes and you have evaluated them. Now, identifying the sensitivity, it means that now there are different attributes in here. This reliability is one attribute, performance is one attribute. Now, what happens sometimes is the attribute gets affected whenever you make change within the system. Whenever any changes are made in the system, so that becomes your sensitivity point. So you're going to identify what are the different sensitivity points within your software architecture. Then the last point is critique candidate architecture developed in step 3. That is when you've identified what is the specific design or pattern that you're using. Based upon that, you're going to critique your candidate architecture using the sensitivity analysis conducted in point 5. That is this, by combining 3 and 5, you're going to critique this software architect. Now, critique means here whether if there is any sensitivity point that is completely changing the functioning of the particular software, then you can change the style or pattern. Now, The next topic is architectural complexity. Now, what is architectural complexity? This complexity, the overall complexity of proposed architecture, that is the software architecture that you're developing, that is called as proposed architecture, is assessed by considering the dependency, that is how much one component or how much the system is dependent, that is called as your dependencies. Considering the dependencies between component, how much one component is dependent upon the other component. So Zhao has suggested 3 types of dependencies. Zhao is a person name. Now the 3 types of dependencies are sharing dependency. Now this sharing dependency, it is going to represent a relationship among the consumer who is going to use the resource and the producer who is going to produce the resource for this very same customer. So that is the sharing dependency. Coming on to the second dependency, that is flow dependency. Now flow dependency, by the name itself, flow dependency means, if suppose we take an example, if suppose you have got 2 components, one component is U and another component is V. So if suppose that U needs to complete the execution before control flows into V, that is the output of U needs to be given as input to V, or U is communicating with V by using different parameters, then it says that there exists a flow dependency between U and V. Then third type of dependency, it is called as constrained dependency. Now this constrained dependency, this is going to represent constraints on a relative flow of control. Here, what is the flow dependency? We know now you're going to have some constraint, that is some limitation among the flow of control between different components. If we take the example of again U and V, if suppose you've got again U and V, now this both components U and V, they cannot execute at the same time. Execution at the same time is not possible. Then there exists a constrained relationship between U and V. So this is a limitation that U and V, both of them cannot execute at the same time. Coming on to the next one, architectural descriptive language, ADL. Now what this ADL is going to provide you with semantics and syntax. Now you are aware of this term that we've studied within ALC. So this ADL, it is going to provide you with semantics and syntax. So this can be used to describe a software architecture interface. Now what is interface? Interface is basically a connection mechanism, how different components are going to communicate. They are going to communicate via using an interface. Now this ADL, this architecture descriptive language, it is going to provide the designer with a few abilities. That ability is going to decompose the architectural component. Now you're going to have one architecture, there can be several components here. So you can decompose all these components. Then next part is compose individual components into larger architectural blocks. Suppose you've got one component, second component is there, 3, 4 different components are there. You can combine all of this different components and make it into an architecture. So we've got decomposing the architecture, then composing the individual components into a larger architectural block. Then third point is represent interfaces between components. Now as you're going to have different components are there, the representation of component, you're going to have a rectangle with 2 protruding rectangles at the left side. So how these 2 different components are going to communicate, that is going to be shown by making use of interfaces. Interfaces are your connection mechanism. This is ADL. Now coming on to the next topic, that is modeling the component level design. Now first we need to know what is the component. Now the definition of component, now this a component, it is a modular. Modular means different modules are there, different components are there. Modules can be different components. Deployable, as within the previous slide I've told you this point, that you can compose individual components into larger components. So these components are deployable, that is they can be placed within an architecture, and replaceable, that is you can replace. If suppose there is a component named 2, you can completely remove that and you can have an updated version that can be a 3. So it is replaceable part of the system that is going to encapsulate the implementation and exposes the set of interface. That is going to tell you what are the different communication points and how this is going to be implemented. This is the definition of component. It is a modular, deployable, replaceable part of the system. Now you have got 3 different views of the component. The first view is the object-oriented view. Now, the first object-oriented view, in this, a component is going to contain a set of collaborating classes. Now, what is collaborating classes? Collaborating classes means classes that are going to communicate. That are your collaborating classes. So within the first object-oriented view, first point is this object-oriented view is going to have set of collaborating classes. You're going to have classes that are going to communicate. Then each class that is there within the component, it needs to be fully elaborated. So the different classes need to be elaborated. Elaboration means you're going to give more and more detail. That is what are the different attributes. Now, if you remember within the class, you're going to have 3 different compartments are there. You're going to have the name, you have the attributes, and you have the operations. So these are the details that you're going to add. Each class need to be elaborated. Then you need to define all the interfaces. Interfaces are the communication points between the different classes. So all the interfaces that are going to enable the different classes to communicate, that needs to be defined. Interfaces need to be defined. Now, to accomplish these 3 things, the designer is going to begin with the analysis model. Is going to take the analysis model and then is going to elaborate each class. As here you know what are the different classes, then second one is elaboration. So you're going to pick the analysis model, you're going to elaborate the different classes and the infrastructure classes. So in this example, we're considering a printing shop. We take an example of a printing shop. Now, the main objective of the print shop is that the customer is going to go to the counter and he's going to tell that he wants to print a file, he wants to print it, Xerox it, or scan. So then the person there is going to tell what is going to be the cost of the printing job, and then that job is going to be passed to an automated production machine. That is, your Xerox machine is going to do the rest of the job. So here, the first phase is your requirement engineering phase. Now, within this requirement engineering phase, an analysis class that is called second. So within the first requirement engineering phase, you've got this first class, that is analysis class. This class is derived. Your print job class, it is derived within the analysis class. Now here, as a print job is derived, you're going to have all the attributes and operations. So if you remember, the second compartment is going to be your attributes, and the third compartment is your operations. Attributes are going to be the number of pages, size, what is going to be the type of the paper, magnification. Then operation is going to be how you're going to compute the cost. That is how many sides are there. If there's a color print or it is a black and white print, based on that, he's going to cost you. So this is the first phase, that is your requirement engineering phase, the first phase. Then the second phase is during the architectural design. That is when you're designing the architecture. At that time, this print job, it is defined as a component. This symbol here, one rectangle with two protruding rectangles at the left side, this symbol is called as your component symbol. This is it is defined as a component within your software architecture, and this is it is going to have two interfaces. Now this lollipop symbol here, this is called as your interface symbol. Interface is your point of communication. So this is first interface is compute job, that is and the second one is your initiate job. Compute job is going to tell you how much is going to be the cost of the Xerox print or scan, and initiate job is when you're going to initiate the job, that is when the Xerox machine is going to start and take the prints. So this is the second phase. At the third phase, now the component level design, it is going to begin at this phase. The component level design is going to begin at this point. The details of the component print job are elaborated. Elaborated means now the first analysis class, it had the number of pages, size, paper type, magnification. Only these four were there. Here you're elaborating on the paper type. What is based upon that paper type, what is going to be the weight, size, and color of the paper. Then you're going to have different color requirements. What are the different production features? All the different options are there. The collation options, binding options, castocks, all this is your elaboration is done. Even within the operation, that is, you had the compute page cost, computing the paper cost, production cost, total job cost, check priorities. Each of these things are expanded. Now here, if you remember the two interfaces, the lollipop type symbols that were present, these lollipop type symbols, these are again elaborated as an interface. Now this interface is represented within a stereotype, that is within these two angular braces. That is called a interface is going to be written, and then the name of the interface will be written. That is your compute job. Computing, now within this compute job, it is going to compute the page cost, then paper cost, production cost, then it is going to add this, and then it is going to give you the total job cost. Then initiate job is when again you're going to define the interface, build the work order. Now whenever you're printing on the printer, it is going to print based upon the order that is being given. That is, if you've printed first file, if suppose two different computers are connected to the same printer, if suppose both of them select print, so which order is taken first, that is going to be printed first. So it is going to check the priority and then pass the job to the production. That is, the printer is going to print that particular file. So this is your object oriented view. The second one is conventional view. Now, in the context of conventional view, the component is going to have the definition as component becomes the functional element of a program. That is going to have a few things. The first one, the processing logic. It is going to have the processing logic. Then the second one, it is going to have the internal data structures. Now, why do you require these internal data structures? So that this logic can be implemented. That was found within the first point, to implement the logic. Then the third point is the interfaces. You're going to define the interfaces. Why you require interfaces? So that you get to know when the components are being invoked, when the component is invoked, and when data is passed. So these are the three jobs of the component within the conventional view. The definition of component changes as a functional element. That is going to provide you three things: processing logic, internal data structures that are required to implement this logic, and interfaces, so that you get to know when component is invoked or when data is to be passed to that specific interface. Now coming on to the diagram here, you have the compute page cost. We are taking part of that diagram and elaborating, which is taking the interface, computing the page cost. Now here you're going to have two interfaces get the job data. For computing the page cost, first you need to identify how many pages were printed or what type of paper that was. It is going to collect all of that. Then access the cost database. That is how much you're costing for one page, how much you're costing for two pages, how much you're costing. It is going to access that database. Based upon that, it is going to compute the cost. Now here, page computing, it is calculate as the number of pages, documents are there, what sizes are there, what are the colors, page size. So this is your elaborated model. Then in the operations, you're going to have get this job data, that is your interface. Then the number of pages, calculate, it is going to calculate whether it is document, site, color, it is going to take all of that and it is going to compute the job. Then this last one is your job size. It is going to compute the cost by taking into account the number of pages, documents are there, what is the base cost, each of the things it is going to calculate, and then you're going to have this job, it is going to tell you the amount that you need to pay. So the third type is the process related view. Now the previous two that we have studied, it is the object oriented view, and the next one is your conventional view. Now within these two views, the component that you're designing, it is designed from scratch. That is, you have nothing. This is developed by taking into account the specifications that are derived from the analysis model. From analysis model specifications, you're going to create a component. Whereas if we come to the process related view, this technique is that you're giving more emphasis on building the system based upon the existing software component. That is, you're going to reuse the different components that are already available, and then you're going to create a design. So this is the software engineering community has emphasized the need to build systems that make use of existing software components or design pattern. So this process related view, it is going to reduce the cost and the time to build the software. Now here you can also have different catalogs are available, or different designs are there. Within the catalog, you're going to have different design, different code level components are going to be there. These all are available to the customer based upon how he wants to design the software. Now, as you're going to have within this catalog, you're going to have a complete description of the different interfaces that you're using within the software. What are the different functions are there, how the different components are going to communicate. All of these things are made available to the customer.